This is part 13 in a series of videos in which I am restoring and repairing an HP9862A plotter. In the videos so far in this series I've repaired the plotter itself, and now I'm working on the interface. Unfortunately it didn't come with an interface, and this is the cable in effect that allows you to connect the plotter to the HP calculator. Now you can buy them on eBay, but by the time I get them into the UK they cost me about £400. I'm just not willing to pay that much, and so I've decided to make my own. That's not to say genuine ones aren't worth that much, they are very rare. I'm just not willing to pay that amount, and also I thought this process might be of interest to anyone else in the same situation where they just don't want to pay that amount of money. Also, this is kind of what I find interesting. I like reproducing this sort of thing, and it's an interesting process to go through. So there are easier ways to do this. You don't need to go to the time and trouble of making the enclosure, for example. You could just get the PCB, put some heat shrink around it, and call that quits. It would work just as well. But I am doing this to try to produce things that are kind of faithful to the originals. I'm not looking for shortcuts, I'm looking for something that looks fairly authentic. Okay, so in this video I'm going to be reproducing the enclosure for this interface. So this is not the correct interface, this is a TTL interface that someone was kind enough to send me, but the form factor, the size and shape is the same, the PCB general size is the same, it's just the actual components on the PCB that are different, but I can use this as a template. Now somebody asked me a very good question in a recent video that wasn't relating to this project, but it was how do I determine the order I go about testing things, and that's very applicable to something like this. Now if I was building this from scratch without access to one of these, it would be very difficult. So in that case I would have to start with the information I do have, which would be the PCB, and that would give me the dimensions of the PCB, and also as closely as I can determine it, the hole pattern, which is obviously what's going to be used to determine where these posts are and where the holes are in the enclosure. But because I have this now, I can use this as a template, and so the order I decided to do this was, I've already designed the board for the interface. I've got some on order, they're not here yet, but the board itself out of this interface can be used just to get the correct dimensions for holes, and the connectors, it will be the same on the other interface as well. So I'm going to start with the plastic enclosure here. Now I've done this already, so I've drawn this up in a 3D CAD program, and I've 3D printed one. So I've kept it as close as I can to the original, and it's a different colour. I don't have exactly this colour material to print it with, but I've kept all the dimensions pretty much identical, so it is very similar. I've made up a sticker for it to make it look reasonably authentic, and this was just a quick rough print. I can print one of much high quality, but even so this still took 4.5 hours to print. But if everything goes to plan, I'll print off a high quality one, and we'll be able to get a very nice looking result. So that's done. It lines up quite well, and if I attach the cable, unfortunately the cable has been cut off, but I can still use it to get the rough dimensions that I need for the interconnection. So that plugs onto the board, and then this assembly, if it's the right size, should drop into the case, which it does, and then the metal cover goes on top, and you've got a slot here that the race section of the grommet sits into. So of course I now need a metal plate. This is metal, and it's got these threaded standoffs pressed into it. So the next thing I had to do was make a plate up, so I've done that. I've made a reproduction, and as you can see it's not quite finished yet. I need to clean it up and paint it, but it's other than that ready to go. Again, I've kept it as close to the original as I can, and this fits nicely into our reproduction enclosure. they are quite snug fits. Okay, so that will press down onto the grommet. So it's quite a tight fit, but this raised section of the grommet presses into this slot, and then the holes on the other side are used to pass screws through. I've threaded the standoffs M3, so these are all threaded, and that connects the two halves of the assembly together. So what I need to do now is go over to the workshop and get this cleaned up and painted, and then the entire thing can be bolted together, and that will be our interface complete. Just a quick note on this for anyone that's interested. If you've ever tried to make anything like this, then there is a complication with this particular component. You can see that I made it pretty much exactly the same shape and size as the original, and part of that are some very tight radius bends, but more importantly, this return depth, that's the distance between where one bend goes one way and where the second bend goes in a different direction. It's only 6 millimeters from this surface to this surface. Now if you got one of the cheap shear brake press machines that you can pick up for a few £100, then you'll know that you can't do this on it the way that it comes. So if you've got one of those machines, I've got a sample here, then the minimum return you can get is 11 millimeters, which is this. So, and also the radius of the bend is quite large. So that's obviously no good for making one of these up. It's the return is double what you need. But I've modified my press brake, and it will now do down to 5 millimeter return. This is 6 millimeters to match what I was trying to achieve with this. This was just a sample. But I thought I'd just show how I've modified the machine to give smaller returns in case anybody else wants to make a similar modification. So we'll just pop over to the workshop and see how to go from 11 millimeter minimum return down to 5, and it is quite a useful thing to do if you do this sort of work. So this is the machine in question. Excuse the mess, this is just sitting in one corner of my workshop, and gets a bit untidy in here, and also hopefully you can see this okay. The lighting's not fantastic in here, but this is a machine I've had for quite a few years now, and it wasn't particularly expensive, but it has been extremely useful. And as you can see, it's a shear press brake and slip roll, so it's kind of a 3-in-1 machine. You can use it for cutting material up to about 3 millimeters thick aluminium, maybe 1.5 mil steel. Beyond that it would struggle, but it does make quite a nice job of cutting. And it's a slip roll, so you can use the rolls at the top to basically curve metal. You can kind of turn them into cylinders or just gentle bends, depending on how you set it. And the bit we're interested in here is the press brake part of the machine, which is the center section, and it's used for creating folds in material. So it will be used for making something like this. This is just a sample I was making to test out our current project. And as you can see, I can do quite short returns. And on the left hand side of the press brake, the minimum return is about 11 millimeters. But the bit we want to look at is the end 8 inches, where I've modified it to allow me to go down to just 5 millimeters. Now, before we go into the modification, I just point out that the narrower the return, the more force is required to actually make the bend. So just be aware, if you do make this modification, don't go too far, otherwise you'll find it extremely difficult to actually generate the bends. And also, I only did the end portion of my machine, so effectively I've now got two separate press brakes, one for thicker material, but where I can't do a shorter return, and then one for thinner material. Probably the maximum now is about 2 millimeters, and it does allow me to go down to 5 millimeter return. So we'll zoom in, have a quick look at the modification, and if you want to make the same modification, you can do it in the same way, or if you've got a better way of doing it, then please let me know. Okay, so you can see the area I've modified at the end here. All it is really is I've machined away 5mm off the front face of the V-block and slide. So I'll just raise or lower the V-block out of the way so you can see it more clearly. And so the modification is just to machine away the front face, but because that would then leave a sharp point at the front of the V-block, you then have to machine down 3mm to take off the top face of the V-block, and that then brings back some width to the front portion of the V. You don't need to go too far, so I've left it so it's about 2.5mm of the front face of the V, and that gives plenty, considering that we can't now fold as thick a material. We just won't be able to because of the we've effectively reduced the distance between the tip of the upper tool and the edge of the V-block. So because we've made that smaller, it requires more force to make the bend. But this is quite a nice modification. It allows me to get very nice short returns. It hasn't destroyed the rest of the machine. I never used to use this for making very wide folds anyway. So I've now got an 18-inch and an 8-inch machine, so it's a kind of a split machine, but it ideally suits what I want. You could of course change this in any way you want. It doesn't need to exactly match the top tool. The bottom of the V is still in the same position on both halves. Obviously you wouldn't fold across the transition because it gives you a very weird bend, but all the top tools are still the same length, so you don't need to mess about with that part of it. And so it's been a very useful modification to this machine. It's made it far more flexible, and is well worth making this modification. It's probably an hour on the mill, and then you've got a very flexible machine. Hopefully that may have been of interest to anyone that wants to make the same modification and be able to make shallower returns. As I say, I had the machine now for around 20 years and made this modification a couple of years ago, and it's made the machine much more versatile. I can make far more parts on it for this sort of work than I could previously. Okay, so the last step in this is to clean this up. I'm going to bead blast it, and then I'm going to paint it, and hopefully it will look much neater. I'm not going to paint it this colour. I don't have this colour plastic, so I'm going to paint it to match the case that I've made. So although this will be grey rather than whatever colour you describe this as, it will look reasonably okay. It's not going to be an exact match of course, but the shape and size of it should be identical. And once we've done that, we'll see if we can actually plug it into the calculator. Okay, I've got the plate painted. I cleaned it up first, just tidied up the corners, made sure there were no rough edges, and then I painted it and baked it, so it's now ready to do the final assembly check of the entire module. So got the board in here. As I said, this is not the final board, this is just the TTL interface board, and all we have to do now is check to make sure that the posts line up with the holes in the case and with the PCB. So okay, so that fits in there quite nice and snugly, goes all the way in, and the top face of the plate, or it's actually the bottom face, is flush with the side of the case. So all we have to do now is hope that the screw holes line up. So we'll try the first one. And that is lined up. Try the next one. And that one also lines up. We'll try the next one. Okay, and one last one. Which also fits. So looks like all the posts are in the right place. Just snuggle those down. Okay, they're all tight. So it appears to fit together quite nicely. Cable support fits. I'll need to redo the cable, of course, and doesn't actually look too bad. So in the next video we'll assemble one of the Reproduction PCBs, which should be here later this week. Make sure that fits into the enclosure, and then we'll try plugging the whole thing into the calculator. And from that point we need to start looking at the ROM module, but okay, that looks like a success at the moment, and as I say, in the next video we'll move on and start assembling what will hopefully be a working module.